Okay guys, here we go. Hints for homework sheet number 3. Let's get started. Question 1 is all about indices. Now indices is just powers, and the rules that we're going to use is that a to the power p times a to the power q is equal to a to the power p plus q. So for example, x to the power 6 times x to the power 7, the answer is x to the power 13. Now if you apply that to the first one, and then the second rule that we're going to use is that a to the power p divided by a to the power q is a to the power p minus q. So for example, if I had x to the power 4 divided by x to the power 1, then the answer to that would be x to the power 3. Okay, so you apply that to the second question. Number 2, straight line. So here we've got the two formulas that we're going to need. We're going to need the gradient formula and we're going to need the straight line formula. Okay. Also what we need is 2 points. Now fortunately in the question we're given those. Those are the points negative 2, 1 and the point 2, 3. Okay, so remember the best way to do these is just to list the points as x1, y1, x2, y2, and then plug these values into the gradient formula up here so you can find out what the gradient is. Once you've got that gradient, we then need to put that value for the gradient and an AB into the blue formula. So where we're going to get our AB from, let's just pick the first two numbers that we've got there. So we have y take away negative, let me fix that. So we've got y take away 1 equals, now whatever you found that gradient to be, bracket x take away negative 2, so that like makes x add 2. Okay, and if you remove all the brackets and tidy it up, you'll get the straight line. Now remember, when you're doing the fractional part for the gradient here, that it's the bottom that you times that side by and the top that you times that side by. Look back in your jot and find an example from Thursday. Question 3, factorising. All you need to remember for the first question is we're going to take a common factor first of all. Once we've taken the common factor, you can then put it into a pair of brackets. For the middle part, we're looking for numbers that add to 6 and multiply to negative 16. So think of all the numbers you can times to get 16. How can you use those numbers to generate 6? Where you've got 3x squared, that's where you do one of these little tables. So we put 3x and x at the top, and then we look at the 4. How can we make 4? 1 times 4, 2 times 2, 4 times 1. What do we do with those numbers? We cross multiply. So we do 3 lots of 4 is 12x, and 1 lot of x is x. Now can I use 12x and x to make negative 4x? I don't think so. Okay, so then you repeat it with the next ones. You do 3x times 2, 2 times x. Right, now can I use these two numbers to make negative 4x? And the answer is yes. I'll let you work out how you do it. Question 4, solving equations. Okay, we've done these ones many times in the past. 4 times 2x, and then you've got negative times negative plus 6 equals 12. I'll let you finish that one off. For the second one, it's a bit harder. It's a fractional one. So the secret here is to get rid of the fractions. So what number does 3 and 4 divide into? And I'm going to tell you it's 12. So put a wee 12 here, a wee 12 here, and a wee 12 here. Okay, why? Because we can now do some cancelling. 3 goes into 12 4 times, so that means you've got 4 lots of this. So you can start it like that, or you can do 4 lots of that, it's 8x, and 4 lots of that, 4. How many times does 4 go into 12? 3. So you've now got 3 lots of this, and 3 lots of that, which you'll write in here, equals, and then don't forget to do 12 times 6. Don't forget to change that to 72. Once you've done that, you should be able to solve it to work out what x is. Question 4, remove the brackets. Well, let's just imagine that 4 is not there to start with. So we do a bit of FOIL, so root 5 times root 5, root 5 times negative 3, root 3 times root 5, and then root 3 times root 3. So get all of that, and it should tidy up to be something nice and easy. Then you can bring your 4 back in, and you can do 4 times whatever your answer up here is to get your final answer. If you remember, the formula for the SIQR is Q3 minus Q1 divided by 2. It talks about SIQR. Now remember, that stands for the semi-interquartile range. Okay, and how we find that is we take our numbers and we write them in order. Now we've got 12 numbers, so there's going to be 6 numbers on the top, and then once you reach the end there, 6 numbers going backwards. Once you've done that, you look for the middle number in the top and the middle number in the bottom, because that's your Q1 and that's your Q3, because you're going to use those in the formula. Back here, 6 numbers on the top, 6 numbers on the bottom, find the middle one on the top, the middle one on the bottom, do your stuff. Second part of the question is to compare how spread. Okay, so how spread out are this set of numbers for S4 compared to the one that it says for S5. And remember, you're going to use words like consistent in your answer. The numbers actually are. Question 7. The volumes are the same, so we'll work out the volume of the cylinder. Now we know what the distance across here is, so we can work out the radius. We know the height, we're told that in the question, so we can get this volume. Now if the volumes are the same, simply we've just got to do L cubed equals this answer. How do you go from L cubed to L? You take the cube root, which should be on your calculator. Lastly, number 8, simultaneous equations. Big problem here, guys, as you've probably noticed, this bottom one isn't in the form that we're used to seeing it. So the top one we're happy with. The bottom one we need to do a wee bit of tidying up. So take the x from there and put it right in the front. So the x from there goes in as negative x. That stays as positive y. And the 3 stays on that side as negative 3. Now it looks like something we can work with. We can do our simultaneous equations. Okay, that's us.